No. Everybody else okay out there? How you guys doing? Have you looked at your quizzes? Do you have any questions?
Yeah, I see what I did.
Okay.
Yeah, I erased. Okay, so I did 2A. I erased it because it got so long. So I tried to make room. And that's when I went to a separate piece of paper. But I could tell you the answer is 1.36 milliliters.
Oh, okay. So just do that on the corrections.
Okay.
Yeah.
That's what I can see. I can see my erase marks.
I got you. Let me see. All right. More people. Are you guys okay? So, I do have a few things I want to talk about, but I want to see first if anybody has questions. Either let's start with a quiz. Any questions from the quiz? And then I'll ask some questions of myself, and then we can move to homework if you guys have any questions from homework. So, anybody have questions from the quiz? Let me mute everybody. You guys doing all right? All right. All right. I mean, okay, so this is an example of something we've seen before. The average was 77, but the real average is higher. There was a couple of grades that were like in the 20s or 40s. So that brought the average down. But I mean, overall, most people did decently well. Let me see. Somebody's got a small truck in the background. Okay. There were a couple of consistent mistakes that people made, especially, all right, so number 2B was definitely the hardest one on there. I think maybe 2 people got it right.
Was that the one where I was I wasn't able to figure out how to convert ounces to cups because I didn't see anything on the, or yeah, that is
Maybe.
the one where I got confused, wasn't it?
Maybe. Let's see who's talking to me right now.
Ian is. Hello.
Oh, Ian. Hey. There is a connection between those two. Yeah.
I think I actually should have pulled this up before I started talking. Sorry.
Sorry. So it's the second line in the conversion under liquid volume. 8 fluid ounces is 1 cup. So let's see. I had a question from somebody about number 3. Oh. All right. So Ian, let me know if you have a question about that, or. All right. Let me know if you do.
They're still figuring out where I stand.
Okay. So there's another question from number 3. So a few people did number 3 and did not do the main thing, the very first word. Right. So if you don't do that, the whole thing is wrong, because the whole idea, I know you could probably punch in the calculator and get the exact answer. That's not the point. The point is, can you round it to a point where you don't need a calculator so you can just get a feel for what it is? That's the whole point of that problem. So if you just plugged it all in the calculator, got the exact right answer, you lost most of the points. Because I didn't want the exact right answer. That's not the point. The point is to not get the exact right answer, right? Which hopefully you understand. Estimation is an important skill to have. So that's why I don't want the exact answer. That's a bad thing to get the exact answer. A couple of people did what used to be the main mistake, which is get the exact answers and then round them. That is not estimation. Estimation is you need an answer, you are out far away from any kind of calculator. Can you just round the number so you can do it in your head? That's the whole point. You shouldn't have to do anything in the calculator for number 3. Nothing. I like it. All right. Is that okay for number 3?
I
think so, because I think I saw the person nodding along. Okay. All right. Anything else from the quiz, guys? No, they got a few more people showing up. Okay. All right. Let me think. What was the other thing I wanted to talk about? There was a lot of there were a lot of mistakes with the first few that dealt with the cylinder and the whatever the hell kind of balls there were. I can't remember. Rubber bouncy balls. Sure, why not? One thing was the units are huge. I would think, you have to know that. That's part of the whole point of this was unit analysis. So if you left the units off, you lost a few points. But what happened is some people were using the cylinder equation when the problem was talking about a ball. So you just have to stop and read a problem. And before you start just throwing stuff into a formula, what's the formula mean that you're using? Does it mean the thing that you're working with in the problem? So you really just have to slow down and say, this problem is about a ball. I better use the formula that's about a ball. I mean, that seems very simple. And I know when the quiz starts and the time starts going, your brain's like, oh shit, just throw things in and pray. But just it doesn't take a long time. Just stop and say, I'm talking about a ball. Which volume is about a ball? All right. Let me think. Was there anything else general about this? Yeah, like I said, 2B, if you do it correctly, it does become kind of long because you have to go from milliliters. What was it? No. I think so. Milliliters to ounces, which could be very many steps. So that problem was specifically about, can you figure out the path to take from milliliters to ounces? That's what that problem was all about. And a few people just misread it, did something else. Many times on this quiz, people did what was in the homework. So I really need you to understand, the things the homework has you do is not the point. It isn't, right? The point of that was getting used to these functions, the volume formula, getting used to these formulas. So I'm not going to ask you the exact same stuff. It was very similar, but it wasn't exactly the same. Let me see. Can you show example of this mistakes? That's what I'm trying to do right now, Salvador. Go ahead. Sorry. Is there a specific question?
I was going to ask about number 1, part C.
Yeah.
So once I got the for B, once I got the thing for the volume for the first ball, and I'm just multiply it by 8, or because it's 8 balls, or that's the one I got confused.
Yeah,
with.
that's it. So it depends on which version of the quiz you had. So your 1C, some people had 4 of them, and some people had 12 of them, and some people had 8 of them, whatever. That's all you got to do, multiply by 8. So quite a few people, let me see. I'm not sure exactly what went wrong. Oh, you know what I think happened to you? I think you cubed. Did you cube 4? Is that what happened? Now I'm curious. Everybody just hang out. Curious what you did. That's what you did. That's what you did. You cubed, but it's not 4.19 cubed, is it? Right? It's 4.19 cubic centimeters.
Oh.
So 2 of them would be 8.38 cubic centimeters. So 8 of them would be 8 times 4.19. That is an interesting mistake. I don't know how you take that phrase I just made. Not a lot of people made that mistake, but that is a mistake that is made normally a lot, which is if I say I got 4 cubic centimeters, that does not mean 4 cubed. That means 4 cubic centimeters. So if I had 2 of those, that would be 8 cubic centimeters. You guys semi with me? So some people let that power on the unit sort of like float over to the number. No, they can't do that kind of stuff. Okay, maybe. That's one reason why this is not really true. But when you hear cc's, I think I told you this, when they say, give me 500 cc's of saline stat, cc is cubic centimeter, right? So now nobody's going to make that mistake. cc, I got 5 cc's. Give me 2 of those. That's 10 cc's. I don't cube anything because it's just a unit of measure. It's just like liters or gallons. Yeah. Does that help? No, Jeff. You suck, Jeff. So, for example, all right. So let's say I do a volume formula. I do the formula and I get volume is poor little dude. You're already dying. 4 cubic centimeters, right? That does not somehow mean 4 cubed. No, right? The centimeters is what's being cubed. There's 4 of these. So if this is the volume of some ball, if I have 3 of these balls, it would be 3 times 4. It would be 12 cubic centimeters then. Yeah, so that guy is on the centimeter. It doesn't affect this number at all. It can't. Otherwise, when would it end? So this would become 4 cubed is 64 cubic centimeters. Oh, wait, I better cube it again. Oh my God, it's getting huge. No. Okay, maybe.
So once you write your problem, you don't bring the cube over to your answer?
So and again, so let's see. Let's do this. There's that problem in the book that's like 14 feet, 16 feet, and 4 inches, right? Remember that problem?
Can you bring the camera up a little bit so we can see the top? Okay. Yes, I remember that though.
All right, and then this one you gotta make into feet, so it becomes 1/3 of a foot. So when you do the volume formula, you get 14 times 16 times 1/3, right? So the volume is whatever the hell that is. I can't remember. Are you gonna try to do it in your head, Jeff? Don't. Come on, just to make a point. There we go. 74 point. Is that right? 74.67. That's what it said, Jeff. Okay. And this would be, I think this was cubic feet. Why would that, so this was 14 times 16 divided by 3 made this number. And then the feet made cubic feet. Is any part of this problem saying to cube this?
No.
No.
Honestly.
Okay, good. And I'm trying to make sure you understand my tone is more of, how do I put this? So it's understandable. So I think I said that earlier. I see that mistake a lot. And it's understandable because we don't work with this much in everyday life. And when we see this, we want to do something with it. But something's already being done with it. It's cubing this. It can't go over there too. Okay, this came from this stuff. This came from this stuff. So, all right. So if I had 3 of these slabs, it would be 3 times this, and that would be it. So everybody had a problem where you had a certain bouncy ball of certain radius. On one problem, you had to figure out one volume, one ball's volume, and then the next problem said you had 12 or 8 or 4 or whatever the hell. So you just had to multiply that by that number. Because if I got 4 of something, it's 4 times that thing's volume. All right. Let me see, I got a lot of chat here. I did that one. Can you show how 2B is freakadelic. Do you use order operations? Order operations is always used, right? When are you supposed to use grammar in language? All the time, right? So order operations is just always there. If you don't follow it correctly, your answer is wrong, period. Always and forever and eternally in every problem. Yeah, okay. Let me see. Okay, so 2B. was the hardest one on there. So let me see, let me remind myself what that started with. Oh yeah, all right, so you gotta love this. So everybody had a problem. It said basically something like it's 16 Canadian dollars, let me just call them CDs, per milliliter. And I have to convert that to American dollars per ounce. So everybody, a lot of people got this step correct because that's very direct. I told you that, what was it? I looked it up on Google that today. So $1 US is 1.33 Canadian. Let me stop for a minute. Right? Everybody had this bad boy. So most people got that step correct. The hard part was changing milliliters to ounces. And the even harder part was to realize that this part B has not a damn thing to do with part A. It didn't mention anything about part A, right? A lot of people were trying to bring your answer from part A in. It didn't say that. It just wanted you to convert so many Canadian per milliliter to so many dollars per ounce. That's all it wanted you to do. It has nothing to do with any other part of that problem. So to go from milliliters to ounces, you look at your chart that I gave you. I can go from milliliters to liters to quarts, all right? So now I gotta think my path. Milliliters, I can go to liters, and then I can look at my chart and I see I can go from liters to quarts. So you guys can see that down there, conversions between systems. And then from quarts, I can go to pints, and then from pints, I can go to cups, and then from cups, I can go to freaking ounces. There it is. That's the path you got to take. So then what do? Well, you just set it up 16 Canadian per milliliter. Let me take care of the Canadian dollars. I forgot already what it was. One of these is 1.33 of these. All right, so now I've got the Canadian gone and it's bucks. So now I got to kill milliliters to liters, and it takes 1,000 of these to make one of those. Then I got to go from liters to quarts. So liters to quarts, and I think it's 1.06. I'm not going to do this whole thing for you. Don't get too excited. And then you go from quarts to pints, and then from pints to cups, and then from cups to ounces. So it's is that going to take a long time? Is it like a long thing? Yes. Is it harder just because there's more little boxes? No. It's just longer. That's all. It's not harder. It's just longer. It just takes longer time. But no, I think maybe one person actually wrote this down. But I think there were about 3 people that got that one right, if I remember correctly. Anyway, so that was the hardest one on there. I will tell you that. But it's not undoable. It's just take a minute and figure out what connects where I am to where I want to be. You got to do that step. And then every step you got is going to be another one of these grids. Every step you take is another one of these little conversion grids. Okay. So not everything's going to be a direct connection. Sometimes there's going to be multiple middle steps. Let me see. I think I'm caught up on chat questions. That should help a lot. I made about a little over halfway through this. You just keep going now. Quarts to pints, pints to cups, cups to ounces. Okay. And be careful, don't put 16. That's the number I made up. You put whatever was on your version of the quiz. Don't be putting no 16. You'll get that wrong real quick. Nobody had that. All right. I think that's everybody. So one thing about math that you have to get used to is that there are formulas that enable us to calculate certain things in certain situations. You have to be sure what situation you're in so you know which formula to use. And then when you start putting numbers into the formula, you got to make sure that it represents what you're plugging it in. So, for example, number 1C, I think I said this earlier, I can't remember. So some of you guys had said you have 8 of these bouncy balls, and some of you guys had said, let's see if I can load this one up. Oh, that's another 8. I don't remember. Some of you guys had said 12 maybe, and some said 3 maybe. I can't remember what. Yeah, there's a 12. Anyway, a decent number of people were putting that number in for R. Right? You're just plugging that number in for R. But what does R represent? What does R represent most of the time in these equations?
Radius.
Radius. So it's not impossible. I want you guys to realize this. I understand when you have a time thing and you get a little, harried and you're like, just do something. It's better than having a blank spot. But when you plug a number in for a letter, what does that letter mean? And does that number represent that? That is the quick mental check, right? If you're going to plug an 8 in for R, you're like, wait a minute, R is the radius. It didn't say 8 is the radius. It didn't say 12 is the radius. So why would I put it there? That doesn't make any sense. So I think one big thing I want you guys to overcome is this need for a problem to be always just put something in and chug it out. No, there is always a little bit of a check. Am I using the formula correctly? Am I putting the number in the right place? Not every problem is just take what I tell you and put it in. That isn't the way it is, which is good, actually, thank God, right? I mean, there's got to be a reason for us humans to be here. And part of it is so we can think about, am I using this thing correctly? Otherwise, just computers could do everything and we would be doing, we'd be like Wall-E, just floating around. Have you guys seen Wall-E? Anyway, I'll stop. Eva, no, okay. Anybody else have any questions before I get into my next thing? All right. So here's the next thing. Here's what's going to happen. I'm thinking we're getting bogged down in section 2.7, and we're not even done with it. And to be honest, I have decided to make it extra credit, and here's the reason. I don't want to get too deep into it because if you take statistics, they will start over. So we've all had a bit of a taste of what standard deviation means. I've shown you what the formula is to figure it out. That's the formula you're going to use in statistics. Depending on your teacher, I always show sort of a shortcut to that formula once people understand the idea. But I want y'all, did everybody hear me? In fact, it says this in Canvas. Section 2.7 is extra credit. So if you started section 2.7 and you want to finish it and turn it in, you can get extra credit for it. The way I work extra credit is if you get it right, I just add it on top of your homework average. So you could end up with above 100 homework average if you do the bonus and get all the other homeworks. Or it could help you if you've missed a few homeworks or something, the little bonus can help you out a little bit, right? If you want to do it. If you don't want to do it, you don't have to. Because you really, really have to get into chapter 3. Okay. All right. So that's what we're going to do. We're going to get into chapter 3. So chapter 2, you only have to do up through 2.6, right? I think I told you I did. Did I tell you that I decided to not even do section 2.8? Why did I decide that? Let me see if I remember. Oh yeah, 2.8 gets way too deep in statistics. This is not statistics class. This is not that. We have a statistics class, so I decided not to do section 2.8. If you take stats, you will learn it. If you don't take it, You're not going to learn. I'm sorry. I'm sorry. Okay. So we're going to get into chapter 3. So let me get this up here. All right. Oops, crap. Let me move you guys over here. Oh, let me see. Where are you, chapter 3? You are on page 291. Shaboo. Oh, have I gone too far? I did. I went way too far. I want 283. So I'm going to be on page 283. And I know they're pandering to me, but I love Back to the Future, so that always works for me, right? Good old 88 miles an hour. Has anybody not seen Back to the Future? I almost don't want to know. Right? Come on. If you've never seen it, I'm sort of upset and jealous because you can go watch it for the first time. Holy shit. I wish I could watch it for the first time again. Anyway, I'll stop. I'm sorry. So this section, we're trying to build up to the idea of slope and equations of a line and all that kind of stuff. So if I say this, does anyone not have a clue what I'm saying? Mx plus b. Y equals mx plus b. Has anybody heard that before? All right, I got a few people I can see that are shaking their head at me. Yes, I like that. There you go, Andrew's with it. Slope, that's what we're building up to. So when they say rate of change, that is the precursor to slope. So we all experience a rate of change all the time. We're all aging. That's a change. Some of us are aging more quickly, maybe. I don't know. We all make money somehow. And there's normally an amount per hour that you get paid. That's a rate of change. Your hair is growing so many inches per week. That's a rate of change, right? So a rate of change is a ratio. Okay. So like 2 inches per month or $10 an hour, right? Stuff like that. So here's 88 mile an hour. The neat thing is I want you to start seeing the connections we can make. That's also a conversion, right? 88 miles per hour. So let me ask you this. Let me connect this with the last thing we were doing with the conversions. Is this plugged in, Jeff? It works better if it's plugged in. I know. Hold on. Bluetooth. All right, thanks, little dude. All right, guys. So real quick. This is a little side note. But it has nothing to do really with this problem. Let me take this up here. So what if I had to go 200 miles and I was going to travel 88 miles an hour the whole time? How would I figure out how many hours it's going to take?
$200 divided by 80. 200 divided
Well, divided by
80.
So, and of course, if I use this, where am I going to put miles? Down there. Where am I going to put hours? There. So I put 88 miles per 1 hour. So now I can just divide. Let's see, 50 divided by 25 divided by 11. 2.2, I don't know, 2.27, 2.28, whatever the hell that is.
2.27.
All right, thank you. So about 2.3 hours, roughly. All right. So that's what we were doing with these before, with conversions. So this is a conversion, but it's also a rate of change. It's obviously a rate of change. So many somethings per time. So, I mean, we start off with some easy questions here. If you were making $100 a day, how much money would you make in 5 days? Number one. If you're making $100 a day, how much would you make in 5 days?
500.
500.
500,
500.
exactly, right? You barely have to, exactly. You barely even have to do any work, right? You can just see that. In fact, we're all used to working with money, so money problems are normally easier. So our $100 a day, so this is so that's $500. Our $100 a day and a $500 per 5 days, are they equivalent rates? Are they the same rate? I love this question because I see some people shaking their head yes. I see other people just staring at me or at the screen. Anybody, are they equivalent rates? And one way to realize that they are is, what can you do with this?
Divide.
What can you do with this? Yeah. So it's $100 a day. Now, what I was hoping is somebody would say, well, no, Jeff, because I got $500 here. But the thing is equivalent rates, right? So you could say, no, this one job is only for a day, but this other job is for 5 days. I can make more money on this other job. Yes, but is the rate of pay different? No, the rates of pay are the same. You guys with me? And you all live this, don't you? Does anyone ever say, man, can I get some more hours this week? Has anyone ever done that? Did your rate of pay change because you were given more hours? No, stayed the same. You just got more money at the end because you worked for more time. All right. We all know this.
Unless you're getting time and a half, Jeff.
Well, good point. Good point. They could give you so many hours you get overtime, but it doesn't happen as much anymore, I don't think.
Time is more expensive.
Sorry?
Time is more expensive than money.
Well, I mean, that's a viewpoint on life.
It's a loss of equity with time. Like, to
All
give
right,
up
all
your, yeah, okay.
I agree. All right, but let's not go further than where we are. What was I going to say? Ah, shit. All right, that's all right. All right. So we are working towards the idea of slope. So everything we're talking about right now is eventually going to be involved with the slope of a line. So number 3 shouldn't be too evil. Can you take a minute and rewrite this so that it's 2 hours down here, not 4? It's got to be an equivalent rate. So right now it's 60 miles per 4 hours. So what would it be? How many miles for 2 hours?
30.
Yeah, I like the way somebody, I think it was Lonell, 30, of course, right? You divide 2 on the top, you divide 2 on the bottom. So one thing I want you to realize is anytime there's a fraction, no matter how it was made, no matter what it represents, you can reduce it, right? You can reduce it to whatever you want, right? So that's something to realize. Just because a fraction is made based on some other kind of problem doesn't mean it's going to act differently than any other fraction. And of course, this one is just, how would I make it with 1 in the bottom?
Divide by 4.
Yeah, if I just divide this all the way, divide by 4, what's 60 divided by 4?
15.
I like it. So to divide by 4, you cut it in half twice. 60 goes to 30, goes to 15. That's how I divide by 4 real quick. All right. So 15 mile an hour, which is roughly how fast you could normally go around 4 o'clock on certain roads. That would be a great speed, actually. That's like, whoa, we're flying. Anyway, so here's where things get a little bit interesting. Take a minute. Don't say anything. Can you convert $320 for 4 days? Can you convert it to being so much money per 10 days? Don't say anything. Somebody keeps leaving and coming back. Who is that? All right. And they give you a hint. They went again. Oh, we got some chat coming in. Oh, okay, okay. Thanks, Ruben. Just I always get a little doorbell when somebody comes in, a little womp womp sound when somebody leaves. All right, who's got a way to do this?
I divided the 320 by the 4 days,
All right,
and I got $80 a day, and I multiplied that by 10.
I like it. Right? Is that right? Did somebody do it a different way? Oh, here we go.
I just
Chat.
multiplied it by 2.
Correct. Thanks, Ryan. I'm sorry. I'm sorry. Cameron, was that you?
Yeah, I just multiplied it by 2.5.
Yes. So if you realize now watch, not a damn thing wrong with this way at all. I want you guys to realize this is beautiful. This is exactly the way to do it. But another way to do it is to say, okay, do you notice how we know this. Whatever I do to the bottom, I've got to do the exact same thing to the top. We know that. Divide, multiply. So if I went straight from 4 to 10, 10 divided by 4 is 2.5. So I must have multiplied 4 by 2.5. So if you multiply 320 by 2.5, go ahead and try it. What's 320 times 2.5? That will get you to 800 also. And that's exactly what we did. If you divide by 4 and multiply by 10, that's 10 fourths, that is 5 halves, that's 2.5. So this 2 steps you can accomplish in 1 step, but you don't always have to do it. Not a damn thing wrong with the way she did it. I like it. So again, all we're doing right now is the same stuff we've always done with fractions, reducing and building them back up. We're just doing it in the context of it being a rate of change. In this case, it's money per day. This case, it's speed, miles per hour, right? But notice how rates always have that per. All right. All right, I'm gonna clear all this stuff. So everybody got what they want from that business? All right. Clearing this away now. It's going. Goodbye. Okay. Oh, I love it. Okay, now, number 6. I love it. Do number 6. I'm not going to say a damn thing about it. And you guys don't say nothing either. Don't say anything. I can use my grammar. I can. Don't say anything. Just try number 6. Oof. Curious how you guys will do it. Some of you guys can do it in a way that you need a calculator, and I'm going to do it in a way that I don't. We'll see. We'll compare. So hopefully everybody can see that you can't really compare them directly as they are. It's not fair because one person got more time. So of course they went further. So just on the face of it, I can't tell who's going faster. So can somebody tell me what they did? Somebody I haven't heard from yet. Can somebody tell me what they did? Don't make me call on you. Let me see. I don't like doing that shit. Anybody who hasn't?
What's the bigger fraction?
Oh, okay, okay. So what'd you do, Vu? For this one?
So I just multiplied 4 by 40, 3 by 50, and whatever side had a bigger number.
Oh, wait. Oh, so you kind of multiply these numbers together?
Yeah.
Okay, that is actually a method you could use. I don't necessarily want that method used yet, but that's fine. That will work. There's another way to do this, though, a little more directly. Somebody else have a different way.
Okay, what did he do, Jeff? I didn't hear him.
All right, so this was, so if I have two fractions, you can multiply these and then compare. So I didn't even put an equal sign. You can multiply those and compare those. I'm not going to get into that because it's good to know that works, but I never am content with that. I would need you to understand why that works. And I'm not going to take that path right now. So, I mean, if I had 1/3 and 3/5, and I want to know which one's bigger, I could actually multiply 5 by 1 and 3 by 3 and determine that way which one's bigger. But I'm not going to go that way right now. I don't want to go down that path. So that will work, Vu. I appreciate that. But let's not go there. Let's stick with this idea of scaling up or down. So did somebody else have a different way? Nobody? You guys were all writing something that I could see. And then I got all the other hidden people. Oh, somebody's chatting at me. Reduce them. Okay, I like it. So how does that work, Kaylee? If you do this one, what do you get?
I think it's like 13.5.
Yeah, let's see. 13.3333, right?
Yeah.
Yeah. And then this one, if you take it down to 1 hour, 4 goes into 50.
12.5.
12.5. So now you can tell who's going faster. It's obviously the dude. This dude's going faster, right? Let me give you a different way. The whole idea is to make the time the same. So then you can compare, right? So what if I do this instead? Let me write this in red. Blood red. All right, sorry. What if I do this? So this is perfect. So now I can tell this one's going faster. This is a perfect way to do it. But let me do this. Let me multiply this by 4. And I'll multiply this by 3. Now, aren't they both per 12 hours? So now I can still tell this guy's going faster. He goes 160 in 12 hours, half a day, and he goes 150 in half a day. So this guy's going faster. Did somebody chat at me? Let me see. Come on, there it is. Yes. Okay, thanks, Ryan. Ryan is my go-to for double checking if my head's on straight. I love it. Yes, Jeff. Yes, just make it the same denominator. I love it. So some of you guys wanted to make them both 1. I just said, let me make them both 12 because then I don't need a freaking calculator. Both ways work fine. They both are the same idea. I like it. I like it a lot. All right, let me clear all that away. What time we got? Okay. It's going to go away. Bye. Bye. Let's see. What? Well, that's easy enough. Oh, okay. So one particular runner jogs 1 lap around a 400-meter track in 2 minutes. So number 7 is just basically repeat to them what they just said. Right? So for every how many minutes they run how far. So there's actually several answers you can give here, but for every 2 minutes they run
400.
400. Yeah, that's pretty much exactly what it says. So if I want to go to fill in this needs to be easy. After 2 minutes, they've gone 400 miles. So after 4 minutes, 2 more minutes, how far have they gone?
800.
800.
800, because every 2 minutes you just add 400 meters, right? So you could just keep going until you go insane. We're not going to do that. We're already all a little crazy. Everybody goes a little crazy sometimes. All right. Blah, 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 blah. So for every 2 minutes, you increase how far they've gone by 400 meters. We're assuming this poor person can maintain this pace for a long time. Keep going. Problem's not done yet. Oh, shit. All right, sorry. So some of you guys that remember slope get the point that this problem is trying to make. And of course, eventually this is going to be like an XY table. In fact, is everybody cool with that if I call this X and this Y? It's like an XY table. We've talked about inputs and outputs before. Can somebody come up with the equation for this? For every 1 minute, the runner jogs how far?
200 meters.
Yeah. 400 per 2, it's 200 per 1. I like it. So eventually, I'm not going to ask you to do this. I'm sure that some of you guys could do this right now, but I can set up an equation for this based on what this says. That's what we're working towards. All right. Let me clear all this away. All right, that's gone. Let's see what else they say about this runner. Yeah, and again, so let's see if you guys remember this. This should be pretty straightforward now, but what kind of growth is that when I keep adding the same amount? Because I kept adding every 2 minutes, I added 400, right? So what kind of growth was, in fact, what 2 types of growth did we talk about?
Linear and exponential.
Kick ass. So which type are we talking about here?
Linear.
Totally. I love it. And I like the way you, linear, Jeff. Okay. And again, number 10 and 11, we already did basically. If they're doing 400 meters every, 2 minutes? Is that what it was? Then that's 200 meters every minute. So that's nothing new. We did that earlier. Okay. Oh, I like number 12. Yeah. Do number 12. Can you guys see number 12? So right now it's 200 meters per minute. Can you convert that to meters per second? Go ahead and try that out.
Hey, Jeff.
Yes.
Hello, Jeff. Can you? Okay.
Yes.
I still have a problem. I have a problem not being able to score like the process when calculating the minutes or from liter to inches or liter inches. I'm still confused. I don't know how to calculate, and that throws me off. I understand that you divide and you multiply, but the confusion for me is not being able to use the formula the way it is.
All right.
So
Here's a great example. You ready? Uh-oh. Sal, hopefully.
Right one time, and then I try doing problems, and it.
Okay, listen. Here we go.
Go ahead.
This is how every conversion works. Which unit do I want to get rid of?
Let's
So
say
I'm
we're trying to get.
Go ahead.
Okay.
Go ahead.
When it says Q, like how would we calculate?
No. Stop. Let's talk about this specific problem right now, because this is related to the question you're asking. So I want to go from meters per minute to meters per second. So what unit do I want to get rid of that I currently have? I want to go from meters per minute to meters per second. So I want to get rid of what?
You want to get rid of minutes.
Minutes. So where would I put minutes so that they'll cancel?
You're gonna. So we have meters on top. We're gonna put minutes on top. It's not gonna be 200 meters on the bottom. You're gonna put.
Because I want to get rid of minutes and replace it with
Seconds.
seconds. And I'm not going to do a damn thing to my meters because I still want meters to be there.
I
in
guess.
this problem. But
When you line up your formula, Jeff, when you line up your formula, are you watching me?
good. Yeah, I'm looking at you. You're on this screen. Sorry, I'm sorry. So when I do this, I'm looking at you. Go ahead.
So when you're lining up your meters, your minutes, and you're doing the formula to the right, you don't do the calculation quite yet. When you do your calculation, you place it on the bottom on a whole different, you set up a whole different new problem again, right? Ask you tomorrow. I'll review what I'm trying to ask you right now. I'll just ask you tomorrow.
But watch.
During office hours.
Just watch. So you're completely, you got this step perfect. You put the minutes there so that it cancel, and I put the unit that I want instead. I want seconds down there instead of minutes. So now if I just put the numbers that connect these two, what connects minutes and seconds?
What connects minutes and seconds?
Yeah.
I mean,
One of these is how many of those?
well, it's like the exact same amount value. The same value.
Let me ask it more directly. 1 minute
Just
is how many seconds? 1 minute is how many seconds?
60 seconds.
There you go. So I put the units. So some of you guys don't trust this process or understand it, which is fine, but you got to ask questions. So I put the unit I want to get rid of across from it, and then I put the unit I want to go to on the other side, right? So now I'm going to end up with meters per second, exactly how I want. And then I put the numbers next to the unit that makes this make sense. I'm never going to put 60 up here. 60 minutes is not 1 second. All right, I like it. Depending on what you're doing, it sometimes seems 60 minutes is a second. All right, I like it. And now, so this is exactly what you said, Sal. Conversion is all about dividing or multiplying. So this thing about unit analysis, what they call dimensional analysis, screw that. It's unit analysis. If you just deal with the units first, the numbers go where they're supposed to go. So it tells you, in this case, I'm supposed to do what with these numbers? What do I do with the numbers? 200's
You're
up
going to
top.
divide on the bottom.
Yeah, you're going to divide. Yeah.
All right.
So it really is that. There's nothing more to it. Why did I put minutes there and seconds there so the minutes cancel? Do I
But
end
I
up with the
understand
minutes
that.
I want? Go ahead, sorry. What's up? Go ahead.
When you're doing like when you're trying to remove cubic meter or like something's confusing me, I'm doing something wrong. Or
is this 3.33, by the way? Anybody?
all right.
So watch this. That was one more thing on the quiz. I'm glad you're asking this, Sal. Very few people got this question right. So there was a problem. It said something like you had 8 cubic inches, and how many cubic centimeters is that? And I know that 1 inch is 2.54 centimeters. This is cubic. So I had way too many people doing this. 1 inch, 2.54 centimeters. How in the world would that get me to the right? I've only got 1 centimeter and I've only killed 1 inch. I've still got 2 inches. So I got to do this a few more times, right? So I don't know if that's your question. I could write that better, but I've got to make sure that I kill everything that's here. If I only write this once, I've only killed 1 inch. I've got to do it 1, 2 more times. Now I've killed all of those. And this will be 2.54 centimeters, 2.54 centimeters, centimeter times centimeter times centimeter. Now I know I'm in the right units.
Okay, and you're gonna times 2.54 3 times. That gives you 7.6.
Times 8. Yeah, so it'll be 8 times this times this times this. Yeah, all the way across. 11. Right, because I have 8, and then times 2.54 times 2.54 times 2.54. All right.
But that gives you 131.09. Okay.
I don't know. Let's see.
All right. I'll ask you tomorrow. I'm just really tired right now.
Sounds about right. Yeah, it sounds about right. Sal, you're fine.
I don't know why I'm asking. I'm all over the place right now, Jeff.
No, you're not. You got to focus on one thing at a time, right? If you get, anyway, so yeah, we'll come back to that. Okay. So I'm going to clear all this on the screen. Let me know if you need it up there still. Anybody? All right, this is all gone away. Where's my chat thing at? What happened to you? It won't come back. Oh, well, too bad for everybody. I'm going to clear this. Bam. Chat, there you are. All right, nobody's chatting me, thank God. All right, shoot. What was that? So what distance? So again, stuff like 13 is going to be simple. If I remember what it was, coming back, get up here. It was 200, if I remember correctly, it was 200 meters per minute, right? That's why I need a better way to write this stuff down. Yeah, 200 meters per minute, okay. So if he's going 200 meters a minute, how far will he go in 40 minutes? How far will he go in 40 minutes? Well, I could just do this, like we've been doing, multiply that by 40. So then I can multiply that by 40. Now I have trouble believing this poor dude can keep up that pace. Or dudette, I guess they never really told us. So 8,000 meters in 40 minutes, if he can keep up that pace, or she. Pace? Pace, there it is, Jeff. What about what distance will he cover in 40 seconds? Somebody remind me, what was our answer for the meters per second that we just got?
Jeff.
Yes.
How do you know that's your final answer for question number 13?
And actually, that's a good question, Sal. What is my answer for number 13?
When do you know when to stop?
No. All right, somebody tell me, what's my answer for number 13?
You said distance. What distance will the runner cover in 40 minutes?
Yes.
8,000.
Already times 40 minutes times 200 meters. 200 meters per minute. So you're doing 40 minutes. Okay, I see. That's the dumb question.
Yeah, so 200 meters a minute. So if it said how far will he go in 2 minutes, I don't even have to think about this. 400 meters for 2 minutes.
Yeah, that was dumb. Or how do you know when not to turn that into a percentage, a decimal? Like if I know, how do you know when to not divide?
Because it's not asking me for a rate. It just wants to know how far. So this part of it will be the answer.
Right.
It's not asking me for a percentage. It's asking me for a distance, right? That's how you know. Don't give me a percentage answer when the question wants a distance traveled, right? So you have to make sure that whatever answer you're getting is actually answering what they want. So if I get an answer like 7.2% and the problem said, how far is he going to go? I'm like, oh shit, I have made a mistake. How far away do you live? 4.7%. What? So I have made a mistake. Okay, I like it. Yeah, so number 15 we know. Does somebody remember the word I used to recall this formula? Distance when you're given the rate of speed and the amount of time. Anybody remember that formula?
Was it XY or something?
Dirt, remember dirt? Distance equals rate times time. Which, again, if anybody remembers this, this is a lot like y equals mx, where b is 0. Now, some of you guys might have forgotten about that. Don't worry about that yet. This is the formula. We've seen it before. Okay. So, for example, just think, if I'm going 80 miles an hour, how far will I go in 2 hours? If I'm going 80 miles an hour,
80 times 2.
80 times 2. The speed times the time. That's exactly what you do. That's the formula we use. So in some everyday situations, the formula makes it harder than what it is because we just do what we know to do. We don't need a formula to tell us what to do because the situation is relatively simple. But this formula comes in handy when the situation is not simple. So thank God we have a formula to back up what we're thinking. But I don't always need formulas, right? I know what to do because we do them out all the time. All right. So that's the thing I want you to realize. And this is going to happen in statistics. If you take statistics, you're going to learn like a lot of probability formulas, but you're barely going to use some of them sometimes because there's an easier way to get a probability than using the formula. There's an easier way to do it if I know how many things I'm working with. So that's sort of like this. I don't have to use the formula if I say I'm going 80 miles an hour. How far do I go in 2 hours? I don't need a formula. I know that's 160 miles. Okay, maybe. But the formula is there. It always works, even when we don't need it. So thank God it works because when we do need it, I want to know it works. All right, so let me clear all this away. Today is just Jeff on a soapbox. I'm sorry. Let me see. All right. So here we're finally getting some actual algebra happening. I love it. So can you take a minute? So you're taxi fare finder, a cab ride. Who takes cabs anymore? From the airport in Las Vegas will cost you an initial charge of $5.10 plus $2.60 per mile. Can somebody tell me then how they got? Is everybody cool with that? Cost you $5.10 just to get in the damn cab, plus $2.60 for every mile driven once you're in. So how did they get this number right there? How did they get this? Oh, I got a chat.
1 mile.
Yeah, if I have the cab go a mile, it cost me $5.10 to get in plus $2.60. So all I did was add $2.60 to get there. So of course, finish this out real quick for me.
So that's the linear growth.
Good. This will be linear, thank God. If taxi fare was exponential, that would suck.
They go out of business.
You'd hope so, yeah. Uber and Lyft and who knows what else would take over, which is basically happening. I went in a taxi ride in Italy, and that was one of the scariest things I've ever done in my life. Don't do that, kids. If you go to Italy, don't take a taxi. Do not. Unless you're all about, almost dying over and over and over. Then do it. It's a thrill ride, I'll tell you that. Yeah, yeah, trust me. Learn from my mistakes. So I could just keep going here, right? So to get the next amount, I'm just gonna add 260 on top. And then to get the next amount, I'm gonna add 260 on top. Keep me honest here. And then, incredibly enough, to find the next amount, this time I'm gonna add 260 on top, just to change things up. So let me ask you this. Let me ask you this. If I start at 510, how can I go directly to this amount? How can I go directly to this instead of having to do bam, bam, bam? And we've done this before. So let me ask you an even better question. What if I wanted to know, what if I have them go 20 miles? What would that be? How much money would that take? Do I have to make this chart go all the way to 20 to do that? What's the quicker way? Every step I added 260, right? So after 2 steps, I add 2 of these. I really want that, you guys, I don't know if you guys are all with me or not. Every step I take, I add 260. So if I want to take 2 steps directly, I would add twice 260. Twice 260 is 520. What's 510 plus 520? 1030. Bam, I got there. So instead of taking 1 step and 1 step and 1 step, I could take 20 steps. So I could start at 510 and I want to take 20 steps and each step is 260. Now that is freaking mx plus b. To be honest, this is turned the other way around. It should be xm the way I've got it. This is mx plus b. That's exactly what that is. But it just makes sense. So you have to differentiate between somebody just told me this shit. Y equals mx plus b. Those insane freaking math people just said that shit. They just made that shit up. No, we captured what the hell we do. That's what formulas do. So that I don't have to freaking go, okay, I want 50. 5, 6, 7, 8. Holy shit. Math says I ain't got that kind of time. Let me write something quicker that'll get me to the answer. That's what formulas are. That's their purpose. So now if I want to graph this stuff, take a minute. I don't know if you've done this yet. Graph these points. Plot those points. What time is it? We're going to head out here in a minute. Let me start doing this with you. So 5 is right in the middle, so it's roughly there. So this doesn't have to be perfect. 770 is really close to 8. 1030 is just above 10. 1290 is almost in the middle. Where am I at? 1550 is 1550. Should be a little higher than that. Too bad, Jeff. And then 1810 is right above 18. Let me see if I can do my, yeah, buddy, this is where this is going to come in so freaking handy. You guys ready for this shit? I'm not ready for it. wait a minute. There we go. Okay. Are you going to work for me? Really? I said I made all this big buildup. Oh, there it is. Okay. God, I don't know what's wrong with this thing. I got a lag. All right, come on. No. Oh, this is really frustrating. There we go. Look at that shit. It's almost good. My scale isn't all that great. Oh, somebody's chatting. Oh, there's a lot of chatting happening. What's going on? It's going to be satisfying. Damn. Off 1 dot. Yeah. So why isn't it perfect? Because I didn't really put my dots perfect, right? Because it's hard to eyeball where 770 is. Obviously, it should have been up higher. But it's good enough for by hand. So that's the connection. That's the visualization of a linear growth. And we know this. It makes sense. That's why we call it freaking linear growth, because it makes a line. And we're really creative with how we name things. Mix a line. What are we going to call it? Let's call it linear. Yeah. So, I mean, that's the connection between linear growth and visually, what does it look like? Blah, 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 blah. Okay. So I need, oh shit, what just happened? Somebody's chatting at me and my chat just went away. I'm sorry. I don't know what you're trying to say. I have no idea how to control this thing. You're not going to come back. Fine. All right. Let me get rid of this. I'm going to clear all this. You guys ready for that to happen? All right, here it goes. Let me see if somebody's chatting at me. It's probably got to do with what I wrote down. Oh, all right. I understand.
What happened to the 20 and all that?
20 what? What do you mean? What happened? What 20? Oh, I'm sorry. You mean that point that I made up?
Yeah,
Why couldn't I? Yeah, why couldn't I plot? Are you talking about why I didn't plot that point?
No, you were asking about a shortcut way instead of going
Yeah. So I could do 5, 10
Yeah.
plus 20 steps, because every step I take is going to add to what was it, 260, right? 260, yeah.
Right.
So if I just do this instead of doing, so how did I get this one? I did 5, 10 plus 1 step of 260.
Right.
So then 5, 10 plus 2 steps of 260 would be this.
Right.
All right, so if I want 20, I would take 5, 10 plus 20 times 2.60. And what would that be? 57.10, I think.
Yep.
$57.10. And maybe your life, depending on what country you're in. Maybe what city you're in. I don't know. I don't take a lot of cabs. Not after the Italy experience. All right. I think that's enough. So I'm trying to get us ready for the connection between what just makes sense and then the algebraic way of showing the connection we're going to make. So that when we do get to mx plus b, it just makes sense, is my hope. All right, but I think that's enough for today. That's not too bad, not too shabby. Oh, the quiz that's currently scheduled for Thursday, I'm going to push it back to next week. We'll talk more tomorrow about when and what it's going to cover. But there's no way we can have a chapter 3 quiz like Thursday. There's no way. So we're going to push it back next week. We'll talk more about that tomorrow. Class is officially over. Let me know if you have a question, if you need to hang out. Otherwise, enjoy your day as much as you can. And thank you for coming. There we go. Everybody good? I'm going to head out if I don't see any questions. Oh, these are all my people that aren't really here. Is that what this is? All right, guys. Bye.